Welcome back, and in the last video we looked at hypotheses and we talked about, null and alternative, sidedness, and then how every hypothesis test must include, or every hypothesis rather, must include a population and a parameter. So let's make sure that that happens in our examples that we go through now. Okay, so I'll let you read the context here for this first one. The thing to note before we actually start this is this little paragraph I have up here. So you have to be able to write them descriptively and in symbols. And we'll do that here. Okay, so the hypotheses, okay, I'm just going to write them, I'm going to leave space for them. Okay, and I'll do HO and H1. Okay, and so it says average birth weight of newborn human babies is approximately 7.5 pounds. Okay, now, okay, and then an obstetrician believes that the average birth weight is different than this. Okay, gotcha. So, I want to write the claim or the new idea, right? And so I'm just going to say that in the alternative, right, the new idea is that the average birth weight of newborn human babies in the US is not, or is different from, right? It says it's different than this, is different from 7.5 pounds. Okay. Now, that's the new idea, but then the null hypothesis has to be what is the current belief or what is the default belief? Like if you didn't have any data, what would you believe by default? Okay. And that is actually the first sentence. Okay. So average birth weight of newborn human babies in the US is 7.5 pounds. Okay. That's actually the first sentence. Okay. So in words, it might be a little bit more straightforward, but now how do you translate that to symbols? Well, think mathematically, okay? In the null hypothesis here, when we say is, that typically translates to equals, and then is 7.5. Now on the other side, I need a symbol, okay? And I'm just going to maybe use B. And what I'm going to define, so every symbol that I use, I have to define. So B is average birth weight, effectively everything before that. So average birth weight of newborn human babies in the US. Okay. All right, so I have that symbol defined, and so it's average birth weight of newborn human babies in the U.S. B is equal to 7.5, and then the alternative hypothesis would just be B is different from, so is not equal to 7.5. Okay, and we're done. Well, okay, actually I missed one thing in the instructions. It says determine sidedness. Okay, and remember the sidedness comes exclusively from the alternative hypothesis. And so since we're saying it's different from or not equal, then this is going to be a two-sided. Because we don't know if it's more or less, we just are interested in if it's different from. Okay. All right, next example. Okay, I'll let you read it. Okay, and so again, if we kind of think about writing this in words and symbols, we can maybe start with the symbols this time, maybe. Okay, so it says you believe. Okay, so this is, okay, when I see you believe, that means, okay, I'm looking at the alternative hypothesis that among U.S. adults aged 18 to 64, the average amount of time each week spent on moderate intensity physical activity throughout the week is less than 150 minutes. Okay, I see a number. I know that's going to be in my alternative hypothesis, and I know it's going to be less than 150, and and what am I saying is less than 150? Well, it's going to be some time, right? And so I'm going to be lazy and just say due to time, I'm going to highlight this. So I'm going to say the variable t is going to be everything that I highlight. So that United States adults age this, the average amount of time each week spent on blah, 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 blah throughout the week. There we go. So that whole thing is T. It's going to take me a lot of writing. Okay. And then, so now that's my belief. What would I believe in absence of any data, right? In absence of data, I would say, well, yep, it's going to be 150 minutes each week. Okay. All right, so now this is correct, and this is also, before I move on, and I'm just going to answer the sideness. If I look at, this symbol, that tells us the sideness of the test, so t is less than, right? So it's going to be to the one-sided to the left. Okay, so now the symbol version of the hypothesis, it looks very neat and nice. When we go to the words, it's going to be long and messy, and effectively have to write a short one-page paper on this whole thing. So I'm going to pause the video and have you try and write out the hypotheses in words, and then resume the video when you are ready to see the answer. And here's what I have. So I did edit it a little bit just so that it made sense grammatically. Don't feel like you have to translate it strictly if you have it in symbols to translate it to words, or vice versa. So you can take the liberty of editing it so it flows nicely. Okay. So we've done 2 examples in this video. The last one, I want you to tackle on your own. I'm just going to give you a statement here, and you develop a hypothesis test. I will provide a sample one, but my sample could be different than yours, and it could be perfectly correct. Okay, so the statement is the Food and Drug Administration recommends 25 grams of sugar a day. I want you to create a hypothesis test out of that. Okay, based on what you believe, or maybe based on what your friend or your neighbor or your brother or sister believes. Okay, so try and write something out, and then just see that it makes sense or is in line with what I have. Well, is similar to what I have here in a moment. And here's what I have. And you'll notice that in my alternative hypothesis, I said it's greater, that the average amount of sugar consumed by U.S. adults each day is greater than 25. And I said that mainly because I know I have a sweet tooth. And if you think about it, everything has sugar in it. So I don't know if that's a good or a bad thing, but it is a thing. And so this is my hypothesis test, and maybe you made a hypothesis test that is similar, maybe you made something that's different. That is okay. The main thing is I want you to see, double check to see if it's roughly in the same form. Okay, you might have less than, you might have not equal, that is fine.